What's up, guys? I'm back, J2 Tutoring with a second video. I'm Jaden Barish once again. Um, Previous video was just a snippet of what we do, factoring just to get us started because it's a universal skill in math. But I figured I'd make a series out of this. So we're gonna do quadratics because that's one of the main applications of factoring, and it'll come into play very nicely. First, I'm gonna go into, how a quadratic is drawn, parabolas, what are the key aspects about it that you need to know. Then I'm going to go into how you solve them. There are a few methods. Probably going to go over two today because I don't want to make this video too long. And then I'll go into something called the discriminant, which will tell you more about the roots. So essentially, a quadratic is really a polynomial, which is just a series of terms of a certain degree with degree 2. So this would be considered a quadratic. Now, the basic form of a quadratic is really like this. This is the basic form of a quadratic. Okay. And A and B and C are just coefficients. They're real number coefficients. They could be imaginary too, but we'll stick with the real number system for now. I'll say when we go into imaginary. Okay. So that's the basic form of it. That's called standard form. There are other forms, but we're going to stick with this today. How is a quadratic drawn? Well, in its most basic idea, x squared is basically drawn like this. It's a parabola. Terrible drawing. There's a reason why I'm a STEM major, not an art major. That's supposed to be on the origin, the 0, 0. This would be x squared. It's basically like a u. Okay. And essentially how you break this down, how do you draw these is by finding the roots and figuring out what sign it is at the beginning. So if you have something like this where it's positive, it's arcing up where it has a minimum, or the vertex is on the bottom. This is called the vertex. Let me get a better picture for you. The minimum is called the vertex. It's right here. It's another form of writing a parabola is vertex form. Or if you have a negative, like it's, I could say, like if it's negative x squared down here, you would flip it. That's called the reflection. We're not going to really talk about that today, but essentially it's like this. Okay. It's a flip. Now that's not negative x squared because our vertex is not on the 0, 0, so I'll just show it. It would be something like that. Okay. Now don't get this confused with a V. This is a U. A V, if you see something like this is not a parabola. This is an absolute value function. Those are completely different things. So it's not this. Okay. It's not a V. Anyway, that's how you draw it, and that's how you notice the reflections too. Now, how do I know where the parabola crosses, where I put it? How do I draw these properly? Or a polynomial in any fashion, basically, but we're going to talk about quadratics. You got to find its roots. But now, what's a root? You're like, what the hell is a root? A root is basically all of the points where x is 0. It's the x-intercepts. That's another way of a root, or they call it zeros. Zeros, roots, and x-intercepts are all synonymous, so the same thing. Now, how do you find them, right? Well, there are a couple ways. It depends on the problem. That dependence creates what type of technique to use. I'm going to show how a factoring one would work. Okay. Now, if you remember, like a good one would be like something like this would be a solid one. Now, this is just an expression. There's nothing to really do with this. You can factor expressions, but there's no solving of expressions. How do you solve a quadratic? Well, it must be set equal to 0. Okay. So if you have something like this, where it's like, oh, I have x squared is equal to like negative 5x minus 6, you got to move this over. And typically I like having the terms on the left side of the equal sign to make it easier. So if I were to move that over, you get this. It must be set equal to 0. It must, it must, it must. Otherwise, this does not work. Now, you're in this position, right? You're like, all right, well, what do I do? How do I figure this out? Well, we could use our factoring techniques from the last video. Use AM in this case. Remember, it's like a riddle. You're like a magician. What adds to 5 and multiplies to 6? In the interest of time, because I went over that in the last video, I'm just going to say, essentially, this is how you break this down. And you could come up with practice problems like this on your own by just multiplying these out and then figuring out what the factoring is, or ask an AI tool, very useful in this sense. But now you're here, right? And now when it's written like this, it's like, all right, well, damn, like anything multiplied by 0 is 0, right? So that's kind of where your head's got to be. So then you split this down the middle. You're like, all right, well, these two are being multiplied. If this is 0, right, then it's 0. If this is 0, then this is 0. So then you're like, okay, well, then if I plug in negative 3, you're good. Because it doesn't matter that this equals negative 1 when you plug it in, right? You get negative 3 plus 3, that's 0. This bulldozes the whole thing. You get 0 over here. So that's set. Same thing over here. You get -2, right? And that makes your equation 0. Now, this are the zeros or the roots, as you like to call them. Now, the reason why setting it equal to 0 is so important is because this technique of plugging in a number and wiping out the rest of the terms does not work if it's set equal to another number. For example, if I have, this is the trap that people run into. If I have something like this, this will not work. Because if I plug in -3, I get 0 equals 1. That does not work. And yes, you can probably find a number that makes this work equal to 1, but it's not as intuitive. It's not as easy. You have to use other techniques to figure that out. What you should have done is move the 1 over from the beginning before you factored. Now, of course, if you move the 1 over, you're not going to be able to get a factoring term. You're going to get this. And then you have to use other techniques. So, in the interest of being, you know, segueing in a really good way and transitioning really well, let's do this problem. Let's say we were presented with x squared plus 5x plus 6 equals 1. And then you're like, all right, well, like Jaden said, I got to move this over and make this 0, right? You do that always. No matter what the situation is, you set it equal to 0 because you're always trying to find the roots, trying to find the x values that make the y 0, right? Because that's what an x-intercept is. It's like this. So, what do I do? Well, I'm stuck, right? I can't do factoring. Factoring's not going to work. There's nothing that multiplies to 5 and adds to 5. So you pull out a few more techniques. One that I like to use, quadratic formula. This will always work. No matter what, without fail, this will work. Now, what is this formula? It's x equals -b plus or minus the square root b squared minus 4ac all over 2a. Now, the reason why I show you that standard of formulas before is because when you see this, you now know what the a and the b and the c are. These are coefficients. So all you do is plug it in, just as it's written in this standard form. That's why standard form is so powerful. Vertex form has its own caveats, and we're going to see vertex form in a second when I do the third technique, but this is essentially how you do it. You plug it in, you're like, all right, well, x is 5, b is 5, so you're like this. And you're like, okay, well, you put this in. You say, okay, b squared, that's 25, minus 4 times 1, and I'll show you a cool technique with this afterwards. But you say that, and then it's all over 2a. Sorry, I meant to put that over 2a. Sorry, this is written poorly. This is supposed to be 2a. The whole fraction, not just the square root. So 2 times a, which is 1, is 2. So now you're here. And you just simplify that inner square root, okay? So you say, okay, so 25 minus 20, that's 5. Now here's what you notice, right? And I'm going to show you something really cool about this. 5. Now, there are always two answers to a quadratic, okay? There are always two because it's a second degree polynomial. Whatever the degree is, and degree is just the highest exponent that any one term has. So x squared is the highest degree you see in the whole polynomial. That means it's a quadratic, okay? If it's a 3, it's a cubic. There's 3 answers. So there's a positive answer and a negative answer in this case. Now, when you have context, you got to be careful. Like right now, we're just solving. So right now, you take both. You take both answers. It's -5 plus rad 5 over 2, and then -5 minus rad 5. That works for both. That will work no matter what. Okay, but here's the problem. Sorry, that's really small. Here's the problem, okay? If you get something like, I don't know, if you're dealing with geometry, geometry is the best example. It's the simplest. You can't have a negative side, right? There's no shot of that. That's crazy. So the -1, the -5 minus rad 5, that's not going to work. Actually, in this case, neither one will work because rad 5 is less than -5. So even if you add, both of these get thrown out. There's no solution sometimes when it's in context. So you got to be really careful when you have context. In this video, I'm just doing conceptual, but like, just be careful of that. If there's no context, then you take both. Or sometimes you get imaginary answers. That's even worse. And I'll show you I'll show you something cool with this quadratic formula. But that's essentially, you use that formula, okay? And there are a couple techniques that I want to teach you with this quadratic formula. One, something cool that I learned is like if you have an even number of b, I'm going to do one where like you can't create a factoring. Actually, yeah, I'll do that. So this one you can't factor, right? So let's say you're set up like this. You say, okay, actually let me fix this. That's not what it should be. Let me talk about this scenario really fast. 4. If b, so the middle term, if the coefficient is even, okay, here's what you're gonna do. You're not gonna do the formula I just said. You're gonna do the half quadratic formula, which a lot of people don't know, where we use k instead of b. K is equal to b over 2. So bear with me. It's half of b. The reason why you do this with An even number is because the halving is easier. It's the entire point. So you have negative k plus or minus the square root k squared minus ac all over 2a. Now I just and all over a. Now I just want to be very clear about this. The quadratic formula will always work, okay? That 4ac will always work. This will not, only when b is even. But this is a lot quicker. Some professors don't even know this. This is a lot quicker because you don't have to simplify. If I kept it as 4, I would have to simplify it completely. But you don't have to in this case. 2 squared is 4. That's how I got the 4 there. I'm just going quickly. This is 1 times 1, and now you're at rad 3, and that's over 1. So now you're just like, oh, straight up, I got the answer. Boom. See, it's right there. If I kept that 4 there, we would have had 16 minus 1, right? Rad 15, then you would have had to take out numbers. It would have been a mess. It would have been 4 times 1. It would have been 16 minus 4 is 12. Then you'd have to take out the 2, and then you divide the 2 out in the a. It'd be a mess. So this is a lot easier. Okay. I just wanted to show that you don't have to use it if you have b as an even number, but it could help you if you remember. I'm here for tricks. Okay. Now something cool I want to show with the quadratic formula too before I show you the final technique of quadratics, of solving them at least, is something called the discriminant. Now, the discriminant is literally just everything inside the square root. Now, I want to make this clear. You're using the normal quadratic formula for the discriminant. You're not using the half angle. Not the half angle, the half quadratic formula. B squared minus 4ac, okay? This is called the discriminant. Now, what is this? This will tell you what type of root you're going to get, okay? It's going to tell you what type of root you're going to get. Now, this is important because you can figure out a lot about something without actually having to solve the entire quadratic. You just have to know what b squared minus 4ac is. You don't even need the square root. It's just for show. But you really just need to know b squared minus 4ac. And I'll give you an example. So for example, like the one that we just did where we had 3 in the inside here, this is a very like standard one. It's for most problems. If you get a positive number, that's essentially not a perfect square, okay? Positive number that's not a perfect square. So if you get positive, not non-perfect, I'll put PSQ, not a perfect square. You have a irrational root, essentially, right? Because square root 3 is irrational. And real and rational plus irrational is irrational, right? Just by standard laws of math. This is an irrational number. So if you have a positive but non-perfect square, it's an irrational number. Now, if you get a perfect square, which I'll show you really quick, remember when we factored? Remember that one? Look, so we had x squared plus 5x plus 6. Let's do that one. So what did we have? X squared plus 5x plus 6. That's, I'm just going to write it again so that I can actually. X squared plus 5x plus 6. You're like, all right, well, b squared minus, you're saying b squared, 25, minus 4ac. You get 1 in here, right? Now that's a perfect square. So if you get a perfect square, okay, that means you should have factored. That means that your roots are real and rational. They're real and rational, okay? Now here's the thing though. You honestly, this is good practice. If you check the discriminant and you could have factored, but you didn't, it's good practice to be able to recognize the factoring after the fact because you know you should have, right? So if you get real, rational, it means it's a perfect square. Now the last two, okay? If you get 0, because that's not a perfect square and it's not irrational either, this means you have a multiplicity. Now I didn't show this one, but let's say you got something like this. X squared plus 2x plus 1. This is a perfect square quadratic. So the square root of this is x plus 1 squared. That means that you have a root that multiplicity 2. It's -1. And by the way, just for completeness, when you're doing this on a test, write multiplicity 2, okay? Don't just write -1. Because remember, there are 2 roots, but they can be the same. It's when they're the same root, you get 0 for the discriminant. Now, I'll prove it to you. B squared, that's 4, minus 4ac, that's 4. You get 0. Okay, so there it is. It's a perfect square. I'm not going to go into completing the square today. I think it'll take too long. I'll go into that in a future video. I'll have a whole video on that because that's vertex form in there too. So I'll end with this. The final one is if you get a negative number inside. This is where you have an imaginary number. A great example of this is x squared plus 1 equals 0. This is a simple quadratic, doesn't require any factoring, but you realize that your roots are x equals plus or minus square root 1 if you square root -1. This is I. Square root of negative 1 is I. And your discriminant will be negative if you're getting imaginary numbers. For example, b is technically 0. You could think of it like that because it's 0x. B squared minus 4 AC, you're getting negative 4, right? You're getting negative 4 in here, okay? That's important. That's important, okay? That means you have imaginary roots because obviously you can't have a negative number inside of a square root, so we call that imaginary because it's not on the real number plane. So that's quadratics in a nutshell. If you want to learn more, of course, visit j2tutoring.com and schedule a tutoring session. Whether it's to help you with school in general, bring your grades up, or you're just have a curiosity for knowledge, I'm open to teaching you new things as well. My tutors have a plethora of knowledge, so whatever you need. If you have any questions, you can leave them in the comments as well. All right. Have a good night, everyone.